Naming using the stock system for transition metals. So, in this example problem, it says which of the following compound names are correct? So, when we're looking at compound names for transition metals, they sometimes are different because the common ions for transition metals can be maybe one of two or three different common cations. They might lose 2 electrons, they might lose 3 valence electrons. So they have different names. So iron 3, this 3 stands for the charge of iron. So it might be Fe3 positive. So when we look at that Fe3 positive, that tells us what the charge is, ion 3, and it also gives us a specific name that we probably talked about before. When it has a higher charge, it's called ferrous. So we use that name ferrous. Even though we call it iron, we use the Latin name and we call it ferrous because it's a different charge than it normally would be. So what we have to do for this problem is use the information that we know about iron 3 being the charge of 3 and see if these compounds actually end up doing the same thing that all ionic compounds do, canceling out their charges. So Fe has a 3 positive charge in this problem, but ClO3 actually is just negative. So when I have 2 of them, which is what this subscript is telling me here, this subscript is telling me I have 2 ClO3s, I only have a total 2 negative charges, and that doesn't cancel out with the 3 positive charges I have here, so A is wrong. Here, tin says that we have 2 positive charge because notice this number in the parentheses, this Roman numeral number is 2. 1, 2. So we have 2 positive. And Cr4 actually is 2 negative. And if you're worried about the polyatomic ions, some of them you have to remember, but some of them will be given to you also. But you have to be prepared to know either remember what the charges are or know where to find the charges of the polyatomic ions. So this has a 2 positive charge, and CrO4 as a whole has 2 negative charge. So tin chromate is actually correct, so B is one of our answers. C, CrCO3 2. So chromium has a charge of 4 positive because when you have this V here, Roman numeral is 5, stands for 5, and then when we have the 1 before it or something smaller before it, takes away one of the 5, which makes it 4. So it has a 4 positive charge, and CO3 has a 2 negative charge. So this is actually correct. Why is it correct? Because even though CO3 as a whole has a 2 negative charge, remember that this subscript tells us we have 2 of them. So that means the total charge is 4 negative. So 4 negative and 4 positive would cancel each other out. So C is an answer to this question. Let's move on to D. This says it's 2 positive. I'm looking at the Roman numeral, so that's 2 positive. NO3 has a charge of negative. And so it says copper. Actually, copper 2, notice how this one though is kind of tricking us because CO is not the name or the chemical symbol for copper. This is actually for cobalt. So we know that D is out of the running. E we have here is nickel. It has 4 positive because again this Roman numeral stands for 4. So it has a 4 positive charge. And C4H6O4 has a net charge of negative. But notice there's only 2 of them, so there's only 2 negative charge, and that does not cancel out with the 4 positive, so that means that E is also not an answer.